Hello everyone and welcome to the lecture on Amazon MQ. So this lecture will contain all these topics. What is Amazon MQ? Difference between Amazon SQS, SNS and Amazon MQ. Brokers. Maintaining an Amazon MQ broker. Active MQ. Amazon MQ for active MQ broker types. Amazon MQ single instance broker. Amazon MQ single instance broker with EBS. Amazon MQ active standby broker for high availability. Cross-region data replication for Amazon MQ for active MQ, then Rabbit MQ, Amazon MQ for Rabbit MQ broker types, single instance broker for Rabbit MQ, and cluster deployment for high availability. So what is Amazon MQ? Amazon MQ is a managed message broker service that facilitates easy migration to a cloud-based message broker, enabling communication between applications. As a message broker, Amazon MQ connects software applications and components, supporting various programming languages, operating systems, and formal messaging protocols. And here MQ stands for message queue. Currently, Amazon MQ supports two engine types. First one, Apache Active MQ Classic and Rabbit MQ. So these two are very popular vendors who had a message queue system or the software, and currently it supports both of them. Amazon MQ is designed to work seamlessly with existing applications and services, ensuring compatibility with your current setup. As a managed service, Amazon MQ eliminates the need to manage, operate, or maintain your own messaging system, reducing the operational burden on your team. So one thing is difference between Amazon SQS, SNS, and MQ. So SQS and SNS also have similar features and technology, but let's see what are the difference. So first one is Amazon MQ, which is a managed message broker service that offers compatibility with popular message brokers. It is recommended for migrating applications from existing message brokers that rely on specific APIs like JMS or protocols such as AMQP 091, AMQP 1.0, MQTT, OpenWire, and Stomp. So if you are already using this software or these protocols, better to stick with Amazon MQ, or if you are migrating from Rabbit MQ or Active MQ, go with Amazon MQ. Coming to Amazon SQS and SNS, Amazon SQS and SNS are queue and topic services designed for high scalability and ease of use. So SQS is for queue and SNS is for topic. They don't require setting up message brokers and are recommended for new applications that can benefit from nearly unlimited scalability and simple APIs. So let's see maintaining an Amazon MQ broker. So Amazon MQ periodically performs maintenance on the hardware, operating system, or engine software of a message broker. And there is a maintenance duration which can last up to 2 hours, and duration depends on the scheduled operations for your message broker. So to minimize downtime during maintenance, you select a broker deployment mode with high availability across multiple availability zone AZs. So we will see for both Active MQ what is this high availability mode, which we can set up for multiple AZs. Multi-AZ deployment modes. Amazon MQ offers different multi-AZ deployment modes based on the broker engine type. So first one is for Apache MQ for active Amazon MQ for Active MQ. So Active MQ provides active standby deployments for high availability and maintenance performed one instance at a time, and at least one instance remains available, and there is an option to configure network of brokers with scattered maintenance windows. And the second technology, which is Rabbit MQ. Rabbit MQ offers cluster deployments for high availability, maintenance performed on one node at a time. This keeps at least 2 running nodes at all times. Scheduling maintenance. So you can schedule maintenance, for example, once a week at a specified time, and the window lasts up to 2 hours. This schedule sets the window for Amazon MQ to start and complete the maintenance action. So let's see now in detail Active MQ first. So first is brokers. A broker is a message broker environment running on Amazon MQ. It is the basic building block of Amazon MQ. The broker instance type is determined by combining the instance class, for example M5, T3, etc., and size, which can be large or micro, resulting in types like MQ.M5, dot large. So all together. So MQ is specific instance types, specifically for Amazon MQ service. Now broker types. So Amazon MQ supports two broker types. One is single instance broker, which operates in one availability zone, communicating with the application and using either Amazon EBS or EFS storage. Then second is active standby brokers, consist of two brokers in different availability zones, configured redundantly, communicating synchronously with the application and using Amazon EFS, Elastic File System. Configurations in Amazon MQ contains all settings for an active MQ broker in XML format, similar to active MQ XML file. These configurations can be created independently and applied to one or more brokers. User management in Amazon MQ involves active MQ users, which are persons or applications that can access broker queues and topics with configurable permissions. Groups serve as a semantic labels assignable to users, allowing for permission configuration to send, receive, and administer specific queues and topics. Amazon MQ for active MQ supports two storage options. First one, Amazon EFS, which is the default Elastic File System, and that offers high durability and replication across multiple availability zones, while Amazon EBS provides low latency and high throughput. Amazon MQ for active MQ broker types. So Amazon MQ for active MQ offers two types of broker deployments. First one, single instance brokers, which is a standalone broker deployment, and second, active standby broker, which is a redundant pair of brokers for high availability. And for both deployment modes, Amazon MQ ensures high durability by storing data redundantly. So this is the active MQ single instance broker. A single instance broker in Amazon MQ consists of one broker located in a single availability zone, and this broker communicates directly with your application. Amazon MQ offers two storage options for single instance brokers. First one, Amazon EFS, providing high durability and availability by storing data redundantly across multiple AZs. And next, we have Amazon EBS, which is in the same availability zone, but it's not spread across like similar to EFS, because EFS is a regional service and this EBS belongs to a single AZ. So this is the only difference with EBS. So we have EBS as well as EFS, two options. And now we'll see Amazon MQ active standby broker setup for high availability. The architecture of an Amazon MQ active standby broker consists of two brokers in different availability zones, configured as a redundant pair. These brokers communicate synchronously with both the application and Amazon EFS. Amazon MQ uses Amazon EFS storage volumes designed for high durability and availability by storing data redundantly across multiple AZs. So in this case, there is no EBS because this has to be available via in the both AZs, and this is a regional service. So in this case, we don't have any EBS. Failover process. So in the failover process, typically only one broker instance is active while the other is on standby. If malfunction or maintenance occurs, Amazon MQ quickly switches to the healthy standby instance. Rebooting a broker results in a failover that takes only a few seconds. For the active MQ web console, Amazon MQ provides two URLs, but only one is active at a time. Amazon MQ offers two endpoints for each wire level protocol, with only one active in each pair. The -1 and -2 suffixes, which indicate redundant pairs. Applications can connect to either endpoint using the failover transport for flexibility. And this is the cross-region data replication for Amazon MQ for active MQ. Amazon MQ for active MQ offers a cross-region data replication feature that enables asynchronous message replication from a primary broker in one AWS region to a replica broker in another region. The failover process is managed through the Amazon MQ API. By issuing a failover request, the current replica broker can be promoted to the primary role, while the current primary broker is demoted to the replica role. The architecture consists of primary and replica brokers in different regions. The primary region contains a redundant pair of active standby brokers, which is primary broker, while the secondary region contains another redundant pair of replica broker. So cross-region data replication serves as a cross-region disaster recovery solution. In case of a primary broker failure in the primary region, you can initiate a switchover or failover to promote the replica broker in the secondary region to primary status. This process reverses the roles, with the former primary becoming the new replica and the former replica becoming the new primary. Now coming to the second technology, RabbitMQ, which is also offered by Amazon MQ. So Amazon MQ for RabbitMQ offers two types of broker deployments. So one is single instance broker, and it's comprised of one broker in one availability zone. This is positioned behind a network load balancer. The broker communicates with your application, and backend is Amazon EBS storage volume. Second type of deployment is cluster deployment, which is a logical grouping of three RabbitMQ broker nodes. Again, it is positioned behind a network load balancer, and this is distributed across multiple availability zone AZs, and nodes, the three nodes share the users, queues, and the distributed state of the cluster. And this is the single instance broker RabbitMQ. So the architecture of a single instance broker consists of one broker located in a single availability zone, positioned behind a network load balancer, and this broker communicates directly with your application. For storage, single instance broker utilizes an Amazon EBS volume. This provides block level storage optimized for low latency and high throughput operations. The use of a network load balancer offers several benefits. It ensures the broker endpoint remains unchanged even if the broker instance needs replacement during maintenance or due to EC2 hardware failures. It allows for continuous connectivity, enabling applications and users to consistently use the same endpoint to connect to the broker. Then cluster deployment for high availability. So this is for high availability setup. So we have three nodes part of a cluster. The architecture of a cluster deployment in Amazon MQ consists of three RabbitMQ broker nodes behind a network load balancer. These nodes share users, queues, and distributed state across multiple availability zones. For high availability, HA setup is ensured through automatic management of broker policies, enabling classic mirroring across all nodes. Each mirrored queue has one main node and one or more mirrors. Operations are first applied to the main node and then propagated to mirrors. A default system policy sets HA mode to all and HA sync mode to automatic, ensuring data replication across all nodes in different availability zones for better durability. So during maintenance, the process is performed on one node at a time, maintaining at least two running nodes. Client connections to the node being maintained are severed and need to be re-established. Queue synchronization occurs when a node rejoins the cluster, which blocks other queue operations. To mitigate the impact, it is recommended to keep queues short during maintenance windows. And that's all. Thanks for watching.